Hello, welcome to AraaTech. For all the viewers and other exciting topic, NER, named entity recognition. Let's start the topic. Named entity recognition, NER, is a fundamental task in natural language processing, NLP, that involves identifying and classifying entities within unstructured text data into predefined categories. What are named entities? Named entities are specific words or phrases in text that refer to real-world objects such as people, organizations, locations, dates, quantities, monetary values, percentages, and more. These entities are typically nouns or noun phrases that convey specific information. Purpose of NER. The primary purpose of NER is to automatically identify and classify named entities within text, enabling machines to understand the content of the text more effectively. By extracting named entities, NER facilitates various downstream NLP tasks such as information extraction, question answering, sentiment analysis, and document summarization. Categories of named entities. NER categorizes named entities into predefined types or classes based on their semantic meaning. Common categories of named entities include person, names of individuals, that is John Smith, Barack Obama. Organization, names of companies, institutions, or groups, that is Google, United Nations. Location, names of places, regions, or geographical features, that is New York City, Mount Everest. Date, specific points in time or temporal expressions, that is January 1st, 2022, last Friday. Quantity, numeric values representing measurements or quantities, that is 10 kilograms, $100. Monetary value, values representing currency amounts, that is 50 pound or $1,000. Percentage, percentage values, that is 50%, 25%. Techniques for NER. NER can be approached using various techniques including rule-based methods, statistical models, and deep learning approaches. Rule-based methods. These methods rely on handcrafted rules and patterns to identify named entities based on linguistic patterns, capitalization, and context clues. Statistical models. Statistical NER models use machine learning algorithms to learn patterns and features from labeled training data. Common algorithms include hidden Markov models HMMS, conditional random fields CRFS, and maximum entropy Markov models MEMMS. Deep learning approaches. Deep learning models such as recurrent neural networks RNNs, convolutional neural networks CNNs, and transformer-based models like BERT have shown state-of-the-art performance in NER tasks by learning complex patterns and representations from large datasets. Applications of NER. NER has numerous applications across various domains. Information extraction, extracting structured information from unstructured text data. Entity linking, linking recognized entities to their corresponding entries in knowledge-based or ontologies. Search and retrieval, enhancing search engines by enabling users to search for specific entities. Named entity disambiguation, resolving ambiguities by disambiguating entities with similar names. Question answering, identifying relevant entities in answering questions based on textual input. In summary, named entity recognition is a crucial NLP technique that involves identifying and classifying named entities within text into predefined categories. By extracting named entities, NER enables machines to understand and process text more effectively, leading to a wide range of applications across different domains. Information extraction. Named entity recognition (NER) indeed plays a crucial role in information extraction tasks. Identifying important entities. In unstructured text data, there can be a vast array of information, including names of people, organizations, locations, dates, and more. NER automatically identifies and extracts these important entities from the text. Organizing unstructured data. Unstructured text data lacks a predefined schema or structure, making it challenging to organize and analyze. By extracting named entities, NER helps in structuring the unstructured data into a more organized format. Enabling further analysis. Once the important entities are identified and extracted, the structured data can be further analyzed using various techniques such as sentiment analysis, topic modeling, and entity linking. This analysis provides deeper insights into the content of the text and facilitates decision making. Improving search and retrieval. NER enhances the search and retrieval functionalities by enabling users to search for specific entities within the text. For example, in a large corpus of news articles, NER can help users find articles mentioning specific people, organizations, or events. Facilitating data integration. NER assistance in integrating textual data with structured databases or knowledge graphs by annotating the text with relevant entities. This integration enhances the interpretability and usability of the data across different systems and applications. Automating information extraction pipelines. NER can be integrated into automated information extraction pipelines where it serves as a crucial component for extracting structured information from unstructured text data. These pipelines can be deployed for tasks such as content aggregation, document summarization, and trend analysis. Supporting decision-making processes. By extracting important entities from textual data, NER provides valuable information that can support decision-making processes in various domains such as finance, healthcare, law, and journalism. For example, in financial news analysis, NER can help identify key companies and their associated events or sentiments. Overall, named entity recognition (NER) plays a vital role in information extraction tasks by automatically identifying and extracting important entities from unstructured text data. This helps in organizing and structuring large volumes of textual data, enabling further analysis, decision making, and automation of information extraction processes. Semantic understanding. Named entity recognition (NER) indeed enhances the semantic understanding of text by identifying entities and their relationships. Contextual understanding. By identifying named entities and their types, NER helps machines understanding the context of a text more accurately. For example, knowing that Apple refers to a company in the context of business news articles rather than a fruit provides crucial contextual information for accurate interpretation. Sentiment analysis. NER aids sentiment analysis by identifying entities that are relevant to sentiment polarity. For instance, in a movie review, recognizing the names of actors, directors, or film titles can provide insights into the sentiment expressed towards them. This contextual understanding enhances the accuracy of sentiment analysis algorithms. Document summarization. NER contributes to document summarization by identifying key entities that represent important topics or themes within the text. Summarization algorithms can prioritize sentences or paragraphs containing these entities leading to more informative and relevant summaries. Question answering. In question answering systems, NER helps identify entities mentioned in the question and locate relevant information within the text. By understanding the relationships between entities, such as the relationship between a person and an organization or a person and an event, question answering models can generate more accurate and relevant answers. Information retrieval. NER improves information retrieval by enabling users to search for specific entities within a corpus of text. For example, a user searching for news articles about a particular company can use NER to filter and retrieve relevant articles containing mentions of that company. Entity linking and disambiguation. NER assistance in entity linking and disambiguation tasks by identifying entities and their relationships with other entities. This helps disambiguate entities with similar names and link them to their corresponding entries in knowledge bases or ontologies, improving the accuracy of downstream NLP tasks. Data integration. Named entity recognition (NER) plays a crucial role in integrating heterogeneous data sources by automatically annotating textual data with relevant entities. Standardizing data representation. NER helps standardize the representation of textual data by identifying and annotating entities according to predefined categories such as person names, organization names, locations, dates, and more. This standardized representation makes it easier to integrate textual data from diverse sources as entities are consistently annotated and categorized. Facilitating data matching and linking. By annotating textual data with relevant entities, NER enables data matching and linking across heterogeneous sources. For example, in healthcare, NER can identify patient names, medical conditions, treatments, and medications mentioned in clinical notes, enabling linkage with structured electronic health records (EHRS) or medical ontologies. Enhancing semantic interoperability. NER enhances semantic interoperability by enriching textual data with semantic annotations. These annotations provide additional context and meaning to the data, facilitating better understanding and interpretation across different systems and applications. For instance, in finance, NER can identify company names, stock symbols, and financial metrics mentioned in news articles, enhancing semantic interoperability for financial analytics and decision making. Supporting entity-based queries and analysis. Annotated with relevant entities, textual data becomes more queryable and analyzable based on specific entities' attributes. For instance, in social media analysis, NER can identify user mentions, hashtags, and URLs, enabling queries and analysis based on user engagement, trending topics, or sentiment analysis. Enabling cross-domain integration. NER supports the integration of textual data across different domains and disciplines. For example, in interdisciplinary research, NER can identify entities such as scientific concepts, researchers, institutions, and publications mentioned in academic papers, facilitating across domain integration and knowledge discovery. Improving data governance and compliance. NER assists in data governance and compliance efforts by automatically identifying sensitive or regulated entities within textual data. For example, in compliance with healthcare regulations like HIPAA, NER can identify protected health information (PHI) such as patient names, medical record numbers, and diagnoses, enabling data anonymization, or access control measures. In summary, named entity recognition assists in integrating heterogeneous data sources by automatically annotating textual data with relevant entities. This facilitates data interoperability, enhances semantic understanding, and supports data integration efforts across various domains such as healthcare, finance, social media, analysis, and interdisciplinary research. By enriching textual data with semantic annotations, NER enables more effective data analysis, decision making, and compliance with regulatory requirements. Search and retrieval. Named entity recognition indeed improves search and retrieval functionalities by enabling users to search for specific entities within a corpus of text. Enhanced precision. NER allows users to search for specific entities such as person names, organization names, locations, dates, and more within the text. This enables more precise information retrieval compared to keyword-based searches, as users can specify the entities they are interested in retrieving. Faceted search. NER enables faceted search capabilities by identifying and categorizing entities into predefined types or classes. Users can refine their search queries based on entity types, allowing them to focus on specific aspects or categories of information within the text. Contextual understanding. By identifying entities and their relationships within the text, NER provides contextual understanding that enhances search and retrieval functionalities. Users can better understand the context in which entities are mentioned, leading to more relevant search results. Improved relevance ranking. Search engines can leverage NER annotations to improve relevance ranking algorithms. Entities recognized by NER can be given higher weightage or importance in the ranking process, leading to more relevant search results that match the user's query. Entity-based navigation. NER annotations enable entity-based navigation within text repositories. Users can navigate through documents or articles based on the entities mentioned in them, allowing for a more intuitive and efficient browsing experience. Semantic search. NER facilitates semantic search capabilities by capturing the semantic meaning of entities mentioned in the text. Users can perform complex queries that involve searching for entities and their relationships, enabling more nuanced and accurate information retrieval. Cross-document entity linkage. NER annotations enable a cross-document entity linkage, where entities mentioned in different documents are linked together based on their semantic relationships. This allows users to explore related information across multiple documents more seamlessly. Personalized search. NER can be used to extract user-specific entities such as preferences, interests, or topics of expertise from user-generated content. This enables personalized search functionalities that tailor search results to individual users' interests and preferences. In summary, named entity recognition improves search and retrieval functionalities by enabling users to search for specific entities within a corpus of text. By providing enhanced precision, contextual understanding, and semantic relevance, NER enhances the user experience and facilitates more precise information retrieval from large text repositories. Knowledge graph construction. Named entity recognition (NER) plays a crucial role in constructing knowledge graphs by identifying entities and their relationships from textual data. Entity extraction. NER identifies and extracts named entities from unstructured text data, including entities such as person names, organization names, locations, dates, and more. These extracted entities serve as the building blocks for constructing knowledge graphs. Relationship extraction. In addition to identifying entities, NER can also capture relationships between entities mentioned in the text. For example, recognizing that John Smith is the CEO of XYZ Corporation establishes a relationship between the person entity, John Smith, and the organization entity, XYZ Corporation. Their relationships provide valuable semantic connections for knowledge graph construction. Graph representation. Entities and relationships extracted by NER are represented as nodes and edges, respectively. In the knowledge graph, each node represents a named entity and each edge represents a relationship between entities. This graph-based representation enables the organization of structured knowledge in a machine-readable format. Semantic enrichment. NER enriches the knowledge graph with semantic annotations by providing additional context and meaning to the entities and relationships. This semantic enrichment enhances the understanding and interpretability of the knowledge graph, enabling more accurate semantic search, inference, and reasoning. Semantic search. Knowledge graphs constructed with the help of NER enable advanced semantic search capabilities. Users can perform complex queries that involve searching for entities, relationships, and patterns within the graph, leading to more precise and relevant search results compared to traditional keyword-based search methods. Inference and reasoning. NER-powered knowledge graphs support inference and reasoning capabilities by capturing implicit knowledge and enabling logical educations. By traversing the graph structure and analyzing the relationships between entities, machine can infer new facts, make predictions, and perform deductive reasoning tasks. Cross-domain integration. NER facilitates the integration of knowledge from diverse sources and domains into a unified knowledge graph. Entities and relationships extracted from text data across different domains can be integrated into the same knowledge graph, enabling cross-domain analysis and discovery of inter-domain relationships. Scalability and flexibility. Knowledge graphs constructed with NER are highly scalable and flexible, allowing for the incorporation of new entities and relationships as additional textual data becomes available. This scalability and flexibility make knowledge graphs suitable for evolving and dynamic knowledge representation needs. In summary, named entity recognition plays a vital role in constructing knowledge graphs by identifying entities and their relationships from textual data. These knowledge graphs represent structured knowledge in a machine-readable format, enabling advanced semantic search, inference, and reasoning capabilities that facilitate knowledge discovery and decision-making in various domains. Entity linking and disambiguation. Named entity recognition indeed assists in entity linking and disambiguation tasks by associating recognized entities with their corresponding entities in knowledge bases or ontologies. Entity disambiguation. NER helps resolve ambiguities by disambiguating entities with similar names or overlapping contexts. For example, the name Washington could refer to a person that is George Washington, a location that is Washington, D.C., or an organization that is Washington Post. NER can disambiguate such entities based on contextual clues and knowledge about the specific domain. Entity linking. NER associates recognized entities with their corresponding entries in knowledge-based or ontologies by linking entities to external sources of structured knowledge such as Wikipedia or DBpedia. NER enriches the understanding of textual data and provides additional context and background information about the entities mentioned, improving semantic understanding. Linked entities provide additional semantic context that enhances the understanding of textual data. For example, knowing that Apple refers to the technology company rather than the fruit enables more accurate interpretation and analysis of text. Supporting cross-referencing. Linked entities enable cross-referencing between different textual documents or sources. Entities mentioned in one document can be linked to their corresponding entries in other documents or knowledge bases, facilitating cross-document entity linking and analysis. Enhancing information retrieval. Linked entities improve information retrieval by enabling users to explore related information across different sources. For example, a user searching for information about a specific person can access additional details from linked knowledge bases such as biographical information, achievements, and affiliations. Enabling structured querying. Linked entities enable structured querying of textual data based on entity attributes and relationships. Users can formulate complex queries that involve searching for entities and their linked properties, leading to more precise and targeted search results. Semantic annotation and enrichment. Linked entities serve as semantic annotations that enrich textual data with additional context and meaning. This semantic enrichment enhances the interpretability and usability of textual data for downstream NLP tasks such as sentiment analysis, topic modeling, and document summarization. Improving machine learning models. Linked entities provide valuable training data from machine learning models, allowing them to learn from annotated examples and improve their accuracy in entity recognition and disambiguation tasks over time. In summary, named entity recognition assists in entity linkage and disambiguation tasks by associating recognized entities with their corresponding entities in knowledge bases or ontologies. This helps resolve ambiguities, improve semantic understanding, support cross-referencing, enhance information retrieval, enable structured querying, and enrich textual data for downstream NLP tasks, ultimately leading to more accurate and meaningful analysis and interpretation of textual data. In summary, named entity recognition is indeed a fundamental NLP technique with wide-ranging applications across various domains. Automatic identification and classification. NER automatically identifies and classifies named entities within text into predefined categories such as person names, organization names, locations, dates, and more, facilitating information extraction. NER plays a crucial role in information extraction tasks by automatically identifying and extracting important entities from unstructured text data, enabling the organization and structuring of large values of textual data. Enhancing semantic understanding. By identifying entities and their relationships, NER enhances the semantic understanding of text, facilitating tasks such as sentiment analysis, document summarization, and question answering. Supporting data integration, NER assists in integrating heterogeneous data sources by automatically annotating textual data within relevant entities, enhancing data interpretability and integration efforts across various domains such as healthcare, finance, and social media analysis. Improving search and retrieval. NER improves search and retrieval functionalities by enabling users to search for specific entities within a corpus of text, enhancing the user experience and facilitating more precise information retrieval from large text repositories, enabling knowledge graph construction. NER plays a vital role in constructing knowledge graphs by identifying entities and their relationships from textual data, enabling advanced semantic search, inference, and reasoning capabilities. Facilitating entity linking. NER assists in entity linking tasks by associating recognized entities with their corresponding entities in knowledge bases or ontologies, helping resolve ambiguities and improving the accuracy of downstream NLP tasks. In summary, named entity recognition is a versatile and essential NLP technique that addresses various challenges in textual data processing. Its ability to automatically identify and classify named entities within text enables a wide range of applications and tasks, making it a fundamental component of many NLP systems and applications.